Hello everyone. Uh, in this video, we will study about Arduino microcontroller. So first of all, we need to understand what is a microcontroller. So a microcontroller is a compact integrated a circuit. We can say it's a IC that contain a processor core, memory, and programmable input-output peripherals. Unlike a general-purpose microprocessor, which is designed for a wide range of applications. A microcontroller is specifically built to control embedded system and perform specific task. Yes, by using a microcontroller, we can perform a specific task using our electronic devices. We can control that electronic devices according to our requirement by using this microcontroller. Microcontrollers are commonly used in various electronic devices and systems, ranging for household appliances and automotive systems to individual machinery and medical devices. They are popular in embedded systems due to their compact size, lower power consumption, and ability to perform specific functions without the need for external component. Programmers need to write a code, or we can say a firmware, for microcontroller to define their behavior and functionalities. Once the code is developed and it's typically loaded into a microcontroller's memory, allowing it to execute the program instruction and control the connected hardware according to our requirement, right? So a microcontroller play a crucial role in our field of embedded system, enabling the automotive and the control of diverse applications in our daily lives. So this is the basic introduction of microcontroller. But here there are many microcontrollers, and here we will study about the Arduino Uno, which is the again it's a type of a microcontroller, or we can say it's a separate microcontroller with a specific features. Okay, so in this tutorial we are going to learn about Arduino board in the block Z. Yes, so we can operate our microcontroller, or we can say that we can code our microcontroller, or we can operate our microcontroller by using the block Z application, as you can study previously in sessions. So it's a Arduino board, right? So Arduino Uno is a type of a Arduino board. In Arduino board, there are certain types, and Arduino Uno is one of the types of Arduino board. It's a microcontroller with certain features, and this board is basically we can use in a very easy way. So for now, we will study about this board, and in this video, we will see some basic concept of Arduino boards, including introduction, types of Arduino, some technical specifications, pins of the Arduino board, and their pin outs, or their specific task of that pin. And the last one is applications. So let's start with the introduction. So basically, Arduino Uno is a open source electronic platform that consists of a physical board and software development environment. The board is designed for easy prototyping of electronics project. It utilizes a microcontroller to interrupt and execute the code upload to it. Yes. So it provide a microcontroller provide a integrated development environment board in our computer. So by using this IED, we will mention address it as a IDE. IDE provide our IDE provide our feature that we are by using a IDE we will code our microcontroller by using our by requirement. And the Arduino platform is a popular due to its simplicity, ease of learning, and standard form factor, which allows for a easy loading of a code using the USB cable, or simplified using a C or C++ languages, or we can use in a certain way we can use block code also. Yes. So by using this type of a coding, we can code our microcontroller and write certain program. Now we will go to the types of a Arduino microcontroller. There are different type of Arduino boards like Arduino Uno, R3 version, Arduino Nano, which has a smaller size than as compared to Arduino Uno, Arduino Micro, Arduino Payable, LilyPad, Arduino Board, Arduino Bluetooth, which consists a Bluetooth feature in the microcontroller board, Arduino Decinella, RAID board, Arduino board, Arduino Mega board, which have a multi-input output or GPIO pins, Arduino Leonardo board, Arduino Robot, Arduino Explorer, Arduino Pro Mic, Arduino Ethernet, Arduino Zero, and fastest Arduino board. These all are the Arduino boards, but with a different specific features. That's why we can separate it in this 16 type of Arduino boards. Let's see some technical specification of Arduino board. So the Arduino board has a 20 input output, or we can say a general purpose input output pins, including 6 PWM pins, 6 analog pins, 8 digital input output pins with a 16 megahertz of a crystal oscillator. Let's elaborate this PWM analog and digital output pins. So basically PWM pins. Here we have six PWM pins. So PWM pins is provide our feature where we can use analog and digital pin both at the same time. So PWM is the full form of the PWM is a pulse width modulation. So in certain case like a servo motor or uh, a very analog output or analog input pin, we can connect that devices as a PWM pins. Here we have six PWM pins. So by use of a PWM pin is provide a analog output or analog take a analog input. So now we will go through six analog pins. So analog pins are just used to just a specific analog input or output pin. And let's learn about eight digital input output pins. By using this eight digital input output pins, we will use this on a digital way, where we need a digital signals or these devices that operate on digital signals or digital input output. We can connect them on this digital input output pins. And the Arduino board has a crystal oscillator which generates up to a 16 megahertz frequency, which we will use in some uh, communication protocols like I2C and UART or SPI and CAN. So every microcontroller need to generate a signal that we can say a carrier signal or a basic controller signal. So this 16 megahertz crystal oscillator is generate that uh, oscillating frequency. We will use this frequency in our signals. Now it also has a Arduino integrated Wi-Fi module. In Arduino Uno board is based on the integrated Wi-Fi ESP8266 module and 8 Mega 328P microcontroller. Yes, this Arduino integrated Wi-Fi module has a special feature like a Wi-Fi, where we need a Wi-Fi integration or a Wi-Fi connection. We can use this board as a Wi-Fi module. The input voltage of a Arduino Uno varies from a 7 to 21. So the operating voltage of the Arduino Uno board varies between 7 volt to 20 volt. Yes. Our microcontroller can operate between this range of 7 to 20 volts. Arduino Uno is automatically pull power from the external power supply. It can also draw power from a USB. We can connect the USB to the Arduino Uno board, and it's automatically pull the power from the USB cable, and it's draw also from the USB. Now we will go to the Arduino pins. So let's see. Let's see some certain basic pins of the Arduino. Here you can see a reset button. By pressing this button, we can reset the memory of the Arduino board. And here you can see the ARF, right? So first of all, we will understand the analog pins, right? Then we will go to the ARF pin. Now, the analog pins are used to take the input of the devices there which can operate on an analog signal, like we can say, or we can take example of LDR, right? So LDR is a light depending register, and when LDR, when the light comes, then resistivity of the LDR is changed due to the intensity of a light. So at analog signal is vary from 0 to certain value, and then certain value to back to the 0. So in this scenario, we can say we take a analog signal from LDR to a microcontroller, and the value of analog signal is vary to the 0 to the certain value, and again from the peak to the low. So analog pins are used to take input of the analog devices. And this ARF pin is used to provide a reference voltage of an analog signal, where you can say that this ARF pin is provide our reference voltage to our A0 to A5, which are the analog pins. Okay, so now here we can see that TX and RX LEDs. Okay, so here we can see that 0 and 1 pin, which is a 0 is a RX and 1 is a TX. So TX and RX pins are basically used to communicate by using a frequency in to the microcontroller and other devices. Or we can say that, for example, in the Bluetooth. So Bluetooth is basically a communication device which can communicate on TX and RX. So TX is basically a transmitting signal, and RX is basically a receiving signal. So where we need a transmitting and a receiving method, we can connect those pins to a 0 and 1. And these TX and RX LEDs are turned on F or and off, or we can say it will blink when the TX pin is on and the RX pin is off, or if is on, or we can say that when transmitting and the receiving processing is going on, then TX and RX LEDs are blink. Power LED indicators. This just indicate the power of the microcontroller at mega 328 microcontroller. This is the heart of a microcontroller. It's basically an integrated circuit, or we can say it's a IC of a Arduino board. This is the at mega 328 microcontroller. Now here we can see that a reset 3.3 voltages, 5 voltages, and ground, and VIN. So by using this VIN, we can provide a power supply to a microcontroller and operate on uh, by using a VIN pin. The ground pin is connected to a negative polarizer, negative supply to the battery. 5 voltage, where a device need a 5 voltage, we can connect the VCC of that devices in our 5 voltages. And as 5 voltage, some devices need a 3.3 voltages, we can connect those VCC pins of the devices to the 3.3 voltages, and a reset pin is used to reset the memory of a microcontroller. Here we can see that the power button. This button is used to provide a power or provide a voltage to a microcontroller. Again, we can see that a voltage regulator. This voltage regulator is basically basically a device that regulate the voltage and give output to as per our requirement of a microcontroller. So now we will go to a Arduino board pinout. As we can see previously, a DC power jack. By using a DC power jack, here we will connect our battery to operate a microcontroller. This is the USB port. By using this USB port, we will code our microcontroller and connect another port is connected to our laptop or a PC. This is the reset button. As I mentioned previously, the reset button is used to reset the memory of a Arduino microcontroller. Let's start with the 0. So here we have a 0 to 13 digital pins which are used to take input or give a output in a digital form to any electronic devices like LED. LED is working on a digital output, and digital waveform are just 0 and 1. So where we need a digital signal, we can use a 0 to 13 pin. Let's start with a 0. So another feature of the 0 and 1 pin is a serial port TX and RX. These two pins are basically used to communicate with other devices. The 0 is used to receive the signal, and 1 is used to transmit the signal. Let's go to a 2 and 3 number pin. It is a digital pin, but the another feature of this 2 and 3 pin is a external interrupt 0 and 1. So basically, we sometime we need interrupts like we use a delay function or a wait function in our coding, where we need to hold our embedded system or hold our application. We need a interrupt for a certain time. So these 2 and 3 number pin provide the external interrupt 0 and 1. Here we have a PWM pins. So basically we have 6 PWM pins as I mentioned previously. So these PWM pins are number 3, 5, 6, 9, 10 and 11. So where we need a PWM communication, we can connect our electronic devices to these PWM pins. So let's discuss some communication protocols. So there are certain communication protocols like I2C, SPI, UART, uh, CAN. So these are the some special communication protocols. So uh, just to use this protocol in certain way, here we have some special pin abilities like for I2C protocol. So here we can see that we have a two I2C protocol connections. Here you can see this number one. So in I2C protocol communication, we need a SCL and SDA, which are the serial clock and serial data. So where we need a I2C communication protocol, we can connect our pin to these devices from here like number 1, and this is the number 2, which are on analog pin 4 and 5. And another protocol is as I mentioned is a SPI protocol. So yes, we can use our SPI protocol in Arduino Uno board too. Here in number 10, 11, 12, and 30. We can see that SPISS, MOSI, MISO, and SCK, which is a SPI protocol communication pins. Here you can see the analog pins. As I mentioned previously, the analog pins are used to take analog signal from any devices which are connected to our microcontroller board. And I clearly see that the analog pins are just used to take a input from the devices. Here you can see this 5 volt, 3.3 volt, 5 volt V in and ground. Our Arduino board is operate on between 7 to 12 volt. So this V in is a power connection for our Arduino board, and 5 and 3.3 voltages are used for to give the power connection to our electronic sensors or devices. Let's see the applications. So where we can use these microcontrollers. uh, in this slide we can see that the microcontroller has a wide use or wide range of a use, right? So we will use in a certain ways, or we can use our microcontroller in prototyping, rapid development of electronic prototypes. We can use this in automation, or we can say that we can use in IoT projects. These are Internet of Things, or we can use this microcontroller on in our robotics, or we can use this on education purpose. So let's see where we can use this, and let's take some basic examples of the applications of the microcontroller that we can see in our uh, daily routine. So system designing, general purpose application, healthcare, education, in mining too, home automation, smart agriculture, in defenses, right? So let's take an example that in a home automation, right? So in a home automation, we can use a microcontroller, and we can see that in this time, we can see the automation is basically performed in our home, where we can see that in the light. So we can use our light not physically, but by using our mobile software. So we will give a signal by using our mobile to a microcontroller, and microcontroller is perform this task as our command that given by our mobile. And in this communication we will use a Bluetooth communication. So by using this communication, we give a command to a microcontroller, and according to our command, our microcontroller is turn off and turn on our tube light. So we don't use to turn off and turn on switch, right? We can operate our home appliances by using a microcontroller, or we can say that we can operate our fan, our AC, our tube light, and our bulb is by using this microcontroller. We don't need to off to the bed and turn off the switch and turn on the switch. We will easily operate our home appliances by using a microcontroller or any communication technique like Bluetooth or a Wi-Fi, right? In defense too, there are some robots are used in a defense of a micro by using a microcontroller, where any soldier or any human being cannot be able to go through it. In that scenario, we can use some defenses robot which can go to that scenario and done some specific task. So there are many applications in these all subjects. So basically, is a microcontroller is widely used in many applications in many ways. So thank you so much.